In this problem, we are given a circuit right here, and we're asked to use the mesh current method to find the mesh current IA in the circuit shown. So in this circuit, when we're using the mesh current method, we're going to have to draw the direction of our current in all of these individual parts. So for our part A, it's kind of already given to us like this. We're going to draw our current this specific way. I'm just using these arrows so it's a little bit more detailed. We have our I of A right here, our I of B right here. I'm sorry, our I of B is up here, and our I of C is to the bottom right. So we have all of these currents. We know all the directions that we're going. We know we need to find I of A. So we're going to be looking at this left part here. So let's start with that. We have a 75 volts. It's going into the positive, out of the negative. So we know it's going down this way. It's going in the opposite direction of our current. That means we are going to have a negative 75 volts. Now we can add all of the resistors for our IA. We have this 2 ohm resistor and this 5 ohm resistor. So we're going to have a plus 7 ohms of resistance for our I of A. Now this is next to our I of B, which is going in the opposite direction. It's going like this. So we're going to have a negative 2 ohms times the current flowing through here, which is our I of B. And then we're going to do the same thing for I of C, but for the 5 ohm resistor. So we have a minus 5 ohms times I of C. This is everything we have in here, so we're just going to set this equal to 0. Now let's look at the current flowing through IC. Well, we can actually use this part right here. This is current. We can see that it's in an arrow like this. It's showing direction. So this is the current flowing through our I of C. So what we can do is have this I of C here and substitute it for a 2 V0 over 5. We need to find our V0. We'll do that in a second, but we notice that for our I of B, we have a current flowing through here as well, this 10 amps right here. And when we look at it, it's going to go down this way, and this way. Well, it is going in the opposite direction of our I of B, the same direction as our I of A. But since it's going the opposite direction of our I of B, it's going to be a negative inside our I of B. So for this I of B here, we're going to write a negative 10 amps. Once we do this, we can start solving some stuff. Our V0 is unknown, so we're going to look for that. We know that voltage is equal to current times resistance, so this is what we're going to write here. Well, our V0 is right here, so we're going to be looking at this part. It's going in this way. So when we write this, we know that I of A is in the same direction as our voltage. So we'll have a parenthesis I of A, and we know that our I of C, which again is this 2 V0 times 5, is in the opposite direction of our V0. So we're going to have a minus 2 over 5 times V0. This is being multiplied by the resistance, which we know to be 5 ohms. So we're going to have 5 ohms here, and this is equal to our V0. Now we can factor this 5 ohms in. Once we do that, I'm going to add the V0s together. So we're going to have a 3 V0 is equal to 5 ohms times I of A. And now we're going to divide both sides by 3 to get our V0 by itself. So if we do that, we're going to get V0 is equal to 5 over 3 ohms times I of A. So we can just plug this into our V0 here. We can say our 5 over 3 ohms times I of A is what our V0 is. Now looking back at our main formula, I'm going to plug everything in. So we know we have a negative 75 volts plus 7 ohms times I subscript A, and then we have a minus 2 times a minus 10, so we're going to have a plus 20, and we have ohms times amps, so this is volts. We have 20 volts right here. And then we have a minus 5. I'm actually just going to write this out the long way. We have minus 5 ohms times our 2 over 5. This is being multiplied by our 5 over 3 ohms times I of A. And I'll just put this in parentheses, all equal to 0. We're going to cancel some things out, so we can see that our 5s will cancel out here. And we're going to also combine some things as well. So we have a negative 75 volts and a 20 volts. If we add these together, we're going to get a negative 55 volts. If we move this to the other side, because it's a constant though, we are going to get 55 volts. Now we just need to solve for the only unknown in our equation, which is I of A. We're going to have a 7 ohm resistor times I of A, and then we're going to look at this part right here. So we have our minus 5 ohms, and I think I made a mistake somewhere in the units, because there should only be 1 ohms here. So I'm just going to omit one of these. That's a mistake. There should only be 1 ohms of resistance, but that's okay. It won't really affect things too much, but keeping units is important. probably should not have counted this resistor right here. So if we go back in our work, we can just get rid of this resistor right here, and that looks good. So we're going to go back. We have our 7 ohm times I of A. This is minus our 5 ohm resistor times 2. So we're actually going to have 10 ohms of resistance, and then divided by 3. So we're going to have 10 over 3 ohms times I of A, and we know that this is all equal to 55 volts. This is our final equation. Now we can just start adding things together and just finding IA. I'm going to multiply our 7 by 3 over 3. That way we have the same denominator. We're going to have a 21 minus 10 over 3. I'm going to divide everything by ohms. That way on our right side we can get amps. This is being multiplied by IA. And then we have a 55 amps. When we put this into a calculator, well, I'll just do 55 times 3. And then we have 21 minus 10, which is 11. So we'll just divide this by 11, and we're going to get 15. So our I of A is equal to 15 amps. This is our answer, and we can write it in here. That's how you solve this problem. If you want more problems like this, there's a playlist link below with a bunch of problems of introduction to circuit analysis, as well as notes to help study for this class.